So we're going to focus on how we name compounds. And to do that, let's first of all look at the summer homework. Um, this is under Chapter 2, Atoms, Molecules, and Ions. We're going to focus first on question 3, and then we'll talk a little bit about writing formulas, as you see there in question 4. So what I've done here is just kind of pasted in a little flow chart, and I stole this from the web, but there's a million of them out there you could look at. And if you remember how to do this, this should just be a review. If not, you might have to go through this a few times. It's a little wordy, but the process is very easy to memorize or just sort of practice and get used to. So let's take an example and see if we can work through it using the flow chart here. So let's say, we're talking about, let's say we want to talk about this compound, NaHCO3. How do we name that? So the first question says, how many elements are in the compound? Okay, so is it 2 or is it 3 or more? Well, we got sodium, hydrogen, carbon, and oxygen. So we've got definitely more than 2. All right, so does the formula begin with NH4? NH4 is ammonium, by the way, which is from your list of polyatomic ions up above. Way up here, here we go. So here is ammonium right there. Okay, this particular compound does not contain ammonium. It's got sodium, hydrogen, carbon, oxygen, so we keep going. So we're going to say no. Then it says name the metal ion, then name the polyatomic ion using your list. Don't change any of the parts of the name. So Na is sodium. Come on, there we go. I'll just type here. So we're going to call this guy, I'll write over here, sodium. I think I'm typing. I don't know what it's doing. Oh, it's entering my text box in a weird place. And then HCO3 must be a polyatomic ion, according to our flowchart. And sure enough, and you do need to start memorizing these. We're sort of picking up on the system for memorizing them, for knowing them. But HCO3 1 minus is hydrogen carbonate. So this compound is simply called sodium hydrogen carbonate. Oops. See how terrible I type this I am. There we go. All right, so that's it. That's the end of the road. Let's try another one. Let's go with COI2. All right, COI2. This is letter C for number 3. So COI2, it contains, how many elements are in the compound? Just 2, cobalt and iodide. Is the first element a metal? The answer is yes. Cobalt is a metal, and we find metals in the periodic table pretty much on the left-hand side. And so left of the little staircase here that goes diagonally through what we call the P block. So cobalt is over here, element number 27, it's a metal. So we're going to answer yes to that question. Keep following our flow chart. All right. So yes, the compound is ionic. Okay, we got that established. We never said that for the other side, I don't think, but the other one was ionic as well, the sodium hydrogen carbonate. But anyway, the compound is ionic. Does it contain a transition metal? And then the transition metals, if we look at our periodic table, are essentially everything from group 3 over to 12 plus the lower left of the P block. So these guys that are kind of in orange and even down here in gray, but really those guys don't really do much for us. So transition metals are in red and orange for the most part on this particular periodic table. So yes, cobalt is a transition metal. Okay. So so we said yes. So it says name the metal, give the charge as a Roman numeral in brackets, then name the nonmetal, changing its ending to "ide." Okay, so for COI2, we are going to say cobalt. We're going to say in brackets 2, and I'll explain that in a second, iodide. So the second element, the anion, which is the negative ion, gets an ide ending. Okay? So cobalt 2 iodide. All right? Now, where did the 2 come from? The 2 came from the fact that iodine is in group 17 of the periodic table, which means, and there it is right there, which means that it is just one gained electron away from being essentially stable or having an octet of electrons, which means iodide, along with fluoride, chloride, bromide, and astatine, will form -1 ions. And because there are 2 of them in COI2, and because the total compound charge has to be 0, that's an important thing to remember, the charge on the cobalt must be +2. And since cobalt can have a variety of charges and different, which is another way of saying oxidation states, we have to list that oxidation state or charge as a Roman numeral. Now there are a few exceptions where you have a transition metal that always has the same charge, and so we don't include it. I don't believe that this particular flow chart addresses that, but they are, and I will outline them here for us. Better use, I guess, I don't know, blue. So technically aluminum's not really a transition metal, but it always has the same charge. Gallium and indium are always +3. Cadmium and silver, I'm sorry, cadmium and zinc are always +2. Silver is always +1. So those guys we would call transition metals, but we would not put Roman numerals next to their names when we're naming them. Okay, last thing here, what if we have a situation like SF6? All right, let's go back to our flow chart. How many elements are in the compound? 2, sulfur and fluorine. Is the first element a metal? No, sulfur is not a metal. It comes from the upper right of the periodic table. Okay, so those are nonmetals. The answer is no. It says use prefixes to name the first element, except don't use mono for the first one. Then use the prefix to name the second element as well. They didn't say this, but you should also end it with "ide." The second element should end with "ide." And by prefixes, we mean the Greek numerical prefixes. So SF6 will be called sulfur, and the Greek prefix for 6 is hexa, and then just not fluorine, fluoride. So we don't have to worry about charges because this is a molecule. It contains 2 nonmetals. So it is just sulfur hexafluoride. Notice not mono sulfur hexafluoride, just sulfur hexafluoride. We leave mono off the first one.